So today we'll be covering, the very basics of what is Avail and how to exactly use it, and what are the different tracks that we have here. So, I mean, the big picture we all know that rollups are taking center stage. We are already seeing a huge explosion of the number of rollups in the space, and these rollups are all hungry for data availability, and that is why we are building Avail DA. It's the data availability focused blockchain powered by KZG polynomial commitments and validity proofs, and also data availability sampling, which is one of its superpowers. Now, in this world of hundreds of general purpose rollups and app specific ones, how will the user experience look like? We think that it will be very fragmented because, as you can see, there are with many different L2s, what's happening with the user experience with different wallets and such. It's very easy to see that there needs to be a force which composes all these experiences together to provide a unified experience. And that's where we come with Avail Nexus. It is a way to unify the rollups across the ecosystem via proof aggregation and data availability sampling. How it works is that we create a coordination rollup on top of the Avail DA, which has two main functions, the sequencer selection and proof composition. By unifying, then one rollup can talk to the another by verifying proofs rather than by relying on the other for executional correctness. So it can verify both executional correctness through validity proofs that the rollups generate and data availability sampling proofs to know that that data is available. Now, once you have the Nexus and the Avail DA, you need a very robust security which anchors the entire protocol, and that is where it comes with Avail Fusion, where we want to have external assets like a BTC and ETH and so on to power the base layer. So that's the what we call as the Avail Trinity. It composes of the Avail DA, the Nexus, and the Fusion. Today, we are going to mainly talk about Avail DA because that is the one which have been developed for some time now. We have been developing it for around 3 years. That's what we are going to launch on mainnet very soon, and it will be very useful if you guys try it out. Let us know, have any feedback on top. So what is this DA and how does it work? So essentially it's a very simple, it's a dumb blockchain. It doesn't do anything fancy. What it does is that when you submit a data blob, it keeps it available. That's the only job almost what it performs. So how you can think is that there are this plethora of rollups which are building on top. You take the transactional data or the state deltas from these rollups and put it on Avail, and then you have verifiability, so which means that you get a guarantee that the data is indeed available. How you do that is you check the availability against KZG polynomial commitments, and you do that using sampling. So you don't need to download the entire data again and then verify whether it's available. What you do is you just check the commitment and then sample bits and pieces of it, and by the cryptographic guarantees that we give, you will be able to get a very high confidence that the data is indeed available. Nexus, again, I will probably skip a little bit on this because this is not probably very relevant, but I'm happy to discuss further with you guys after this presentation because I have been put on a very tight schedule here. Same with Fusion, just that one of the core features that we want to have here is that all these assets should play a role natively inside the consensus, and that is going to be extremely important because we don't want to create extraneous forces outside the consensus system that affects the outcome of the protocol. We want to bake it all inside the protocol, and that's one of the core differentiators from other solutions in the space. And that's how we think that Avail will accelerate the unification of Web3. Let's talk about the DA a bit more. As I said, it's just a modular blob space, right? So it has a very simple way of publishing the data. Each rollup build that is built can interpret and define its own transactions. So we as Avail do not interpret transactions. We do not decode it or anything. You can build anything completely custom. You can have your own state transition functions built on top. You can have anything from EVM to no VM at all. And we will probably come a bit on that as well today. One of the, like a good thing to note here is that you can segregate the transactional data per application based on something that we call application ID. So if assume that there's this Avail block and all of you here use the same block to submit all the data, then to know which part of data is important for your application. You don't want to download your peer's application data, right? So how you segregate is that you create an application ID, and against that application ID you send the data, so that you can get back only those parts which are relevant to you and not the entire block, because the block can be pretty big for your application. As I said, we use polynomial commitments and data availability sampling. What you can think of here is there are 2 or 3 modes in which the light client can work. One is what we call as a sampling mode. In the sampling mode, how it works is, as I mentioned, you randomly select a few parts of the data, get them back, and check it against the commitments. That's your guarantee that almost entirety of the data is available. This guarantee only comes because of the erasure coding there. So for a block producer, it's extremely hard to censor parts of the data, because if you censor a single part of the data, you have to hide a lot of them, and if you hide a lot of them, then by sampling you will be getting caught. And that's one of the reasons why data availability sampling is so powerful. There's another mode in which you can run, which is called application full nodes, in which, as I said, you can download only the part of the data which is relevant to you. So you run a light client, but you feed it a particular application ID which is relevant to you, so that you download only the parts which are relevant. Now, what this all allows is that there's a vibrant ecosystem waiting to be built on top. Right now, we have all seen about the Validiums, the EVM general purpose chains, but there's a lot more that you can build. You can build an infrastructure on top, like an L3 sequencer. You can build a Validium. You can build state verifying bridges and use asynchronous composability among these rollups. You can have shared security because your Avail DA acts as the source of truth for the entire ecosystem. Roughly speaking, again, not super relevant, but it's good to keep it in the back of your head if you are building something on Avail. What the Avail block does is that you take the original data, you extend it. That's the erasure coding part, which makes it highly hard for a block producer to suppress parts of the data. You encode them all up inside the header. The header goes on to all the validators, and if you suppress only a part of the data, then also you can catch it, because that's how sampling will work. I'll probably ignore a bit of these things here, but again, one of the things which are relevant here again is how we compute those commitments. If you have the data blobs like this, we take it as a matrix and we create commitments. How many commitments do we create? We create 256 commitments. If you have seen the latest EIP 4844, and we will come to a bit of it. How EIP 4844 works is that you have at most 6 blobs, each of 128 KB. Here we have 256 blobs, each of 256 cells, and each cell is 32 bytes. It's the same cell size, is the same curve that EIP 4844 uses. So that's one of the the good things that has happened, because currently all the rollups have switched to blobs or are switching to blobs, and blobs are the native data structure which is supported by our chain, and it uses the same KZG commitments which are used in EIP 4844. We use a consensus called Babe and Grandpa, and there are, of course, tons that I can talk on top of it, but the main thing for you to know is that if you send a particular data to a block, the block will get finalized in almost around 60 seconds. So 20 seconds is our block time, around 40 seconds to finalize that block. So it gets a total of around 60 seconds. If you use any other DA layer, that is any other DA layer, you will get a guarantee of data availability much, much later than this, orders of magnitude later, because Ethereum finalizes every 12 to 15 minutes, and any other protocol might rely on fraud proofs, so they have much delayed guarantees of DA. No need to go into the staking details, but that is one of the core, decentralization factors that we have on our chain. We use something like nominated proof of stake, which uses a fragment election algorithm on behind the scenes, and that's what keeps our validator side very much decentralized. And you cannot, even if you try to centralize it using a huge amount of stake on all delegated into a single validator, the algorithm will not select your stake. This is one of the major parts where the differences lie. This is the light client network. There are the blocks. As I was mentioning, there is sampling, but these light clients form a peer-to-peer overlay network of their own, which means that the light clients can host an entire block replica. Not going into much of the details, we will see a little bit of that. But what can you build on Avail? Right? We will give you some more examples, but you can build anything from validiums to optimistic chains to sovereign rollups to app-specific ones to general purpose ones to even L3s, L4s, God knows what, right? So anything which needs a transactional data on to be secure, you will be needing a DA layer, and you can try out Avail. This is the part about the bridge. How Avail and Ethereum talk to each other is through an attestation bridge. It's a ZK verified light client based bridge that we have built in collaboration with Succinct. It uses, like, the Ethereum blocks are verified inside Avail and vice versa. That means you can have the attestations that you get on Avail, you can propose them to the Ethereum, and that is one of the ideas that we have for you guys, is to try out the bridge, either to make a JavaScript SDK on top or to make this Validium using the bridge. Probably you guys know all about what are sovereign rollups and how it works and so on and so forth. Let me get into concrete details right now about the tracks that we have. This is track 1. The track 1 has almost nothing to do with Avail. What we want you is that create the best visualizer that we have for pre and post EIP 4844 and compare the cost and the benefits that we have after EIP 4844 came into place. There is a $2,000 bounty which we want to give to 2 people. The criteria for evaluation is the number of rollups that you can support. Now, mind you that there is a certain diversity in types of the different rollups that you can build. So for example, if you take a look into something like, let's say, L2Beat, and maybe I can open it as well for you to see. If you see L2Beat and you go through all the rollups that are mentioned, you will see that Arbitrum 1 is a type of its own. So it uses the Arbitrum Orbit stack behind. If you see the OP mainnet and the Manta Pacific, they are both using the optimism stack. So by looking at the optimism stack only, you can cover a lot of these chains that are there. Similarly, you will see that ZK Sync Era is a chain of its own, but there are others like, for example, the Starknet, DYDX, Immutable X. They are right now using the stack. And how do you know the stack? You will see that with what stack was it built. So when you support a particular stack, you can support multiple of these rollups. So you can take your pick about how do you build the best visualizer and make the most of the chances that you have. We will be evaluating by the diversity in types of the stacks that you support, but also the number of L2s whose costs are being visualized. Of course, the design and presentation is going to be key because we want it to be the best visualizer that we have. There are a few others that are there in the space, and that's also good to see. For example, there is this blob scan, which you can see that for every block, how many blobs did it contain. And as I was mentioning, on Ethereum, right now you have 6 available blobs, but only 3 on average because of AIP of 1559, AIP 1559, which says that on an average the capacity will be half. Just like in the transactional gas estimation things, you have around 30 million block gas limit, but only 15 million on average. Here also you have 6 blobs in total, but only 3 blobs in average. And that's something to see here. Also, one of the things that to mention here is that even if rollups are using the blobs, they are not using it completely. They are using it partially, and that's also something that you can show, because if they are not using a blob completely, and this has been happening in Starknet, so from EIP 4844, we kept on they kept on increasing the capacity utilization, and right now they are reaching around 60 to 70% of the blob space utilization, and that's very good to see on an explorer like this. So that's something that you might want to consider. Right now, as of today, as far as I know, ZK Sync, Starknet has already, and Optimism has already started using blobs. Arbitrum DAO has already approved, may have been already included. I have not seen the latest, but these are all using EIP 4844. So there is a lot of comparison that you can make. One of the bonus points that we want to give here is the simulation of congestion. So suppose you have all the rollups, sending all them not as call data but as blobs. If that happens, then the amount of congestion and the cost estimation, if you can provide that inside the visualization, then we will give you bonus points there. Hopefully that makes sense. If not, let's talk outside or after the presentation to discuss some more of these details. Last thing here, yeah, I think here also, as you will see, that ZK Sync, Optimism, Base, they have all started using blobs. In each of these blobs is 128 KB. You see there's a fixed size of blobs. This data, sometimes you will see a lot of zeros amended. Of course, there is a filled up blob, so might not, like, it might be fully utilized or almost fully utilized, but sometimes you might have padding on the end, which will tell you like how much of it is being actually used. Now comes the interesting track, which is around $3,000, three each of $1,000, I guess. Here, build anything with Avail, and we are not trying to give these as pointers of what you should build, but these are just some suggestions about what are the kind of things that you can build using Avail. The first is build a custom application specific rollup. What that means is use any stack of your choice, be that Madara. On Madara we have docs. You can just pass a command line argument while using the Madara stack by the Starkware guys, and you can use Avail DA out of the box. When you use Madara, then build something cool on top and show that it is using Avail, and let's see the impact that you can make by using something novel. Role kit also, we will have all of them in the docs. You can check out the docs and see step by step about how to use Avail using role kit. What role kit enables is that you can use any Cosmos SDK chain. On the latest version, any Cosmos SDK chain can be used to build a rollup on Avail. RISC-0 and SP1, both of our partners, what they do is that you can take any C++, Rust, mainly Rust I would say, program which compiles into LLVM and make a verifiable compute on top. What that means is that with this, you can have any arbitrary logic as a Rust program and building that as a rollup on top, right? And that's one of the powerful primitives that you have today. What you can build on this, let's say an order book exchange rollup, right? Now if you think about an order book exchange, till now EVM had severe limitations of the type on the kind of things that you can build, the amount of state that it can support, the number of loads, like the number of reads and writes that it can do, the amount of order matching that you can do off chain, and the verification that you can do on chain, and so on and so forth, because you didn't control the protocol. You do not control how your transactions are selected from the mempool. You only control the EVM compatible logic. Here, with an application specific rollup, you can control everything, starting from your sequencer, which decides which transactions get in what order, to the executional guarantees that you want. What do you want off chain? What do you want on chain? What are the verifiable parts? What are non-verifiable parts? You can decide, and that makes you able to build a lot of different things which you couldn't have been building in a general purpose chain. Of course, for this to be eligible, I think you will have to use Avail as a DA, of course. And I think there are other tracks from many of our partners who have also had bounties if you build something on the DA space. You can build a liquid staking protocol for Avail. One of the core problems in a liquid staking protocol is that Avail does not support smart contracts. What that means is that if you have to build something, either you will have to build it directly on the node as a pallet, or you will have to use Ethereum to build something and then bridge assets. Now, while bridging assets, you will have to also think about how your tokens which have been staked on Ethereum, how they will be bridged through the bridge and then directly staked on the protocol. So that's one of the tricky parts of building a liquid staking protocol for Avail, but you can be innovative. There might be things that we have not thought about, and you might be able to unlock one of them. Again, take a look into the other tracks. Maybe some of them are also eligible for other prizes elsewhere. This is something pretty cool in my opinion. If you check out our light client, our web light client is a simple page. What it does is it does the sampling. So as you can see here, it's a very small block that we have here, but again you see that it got changed and the next block was pretty big. This of course inflates and deflates per demand, and this is the live sampling that is happening. One of the things that are lacking here is that of course everything happens here, but there's no peer-to-peer connection, and we definitely want to rely on peer-to-peer more than we want to rely on RPCs. This is all built in RPCs. All the KZG verification is happening inside the browser, and that's one of the cool features that we have here. What you can do is you can add peer-to-peer support on top, and here you can use a JavaScript lib peer-to-peer library to make it on the JavaScript side, or you can use it on the Rust side by using Wasm, and this application right now already uses Wasm to verify and Rust code. Again, more and more ideas. We have a bridge API which is powered by Rust. It connects and uses people can use this API to send transactions from one side to the other. You can build a JavaScript SDK on top so that wallets can use that for bridging. These are some of the more advanced. If you are interested in peer-to-peer, there's an address book that you can build. You can detect the addresses, you can store it all. There are some bonus points about how you keep the mapping, the WebSocket communication versus a TCP communication versus a bootstrap node or a non-bootstrap node, and so on and so forth. There are other things which you can build if you are more interested in something like IoT, if you play around with Raspberry Pis and others. If you can build, if you can embed the Avail Lite client inside the Raspberry Pi and build a web app on top, that would be a cool thing to build for the entire community, because our decentralization depends on the number of Lite clients and the ability to run Lite clients, because we give the highest form of guarantees to our Lite clients. I think these are all Q&A, but before I go there, let me be a little bit more hands-on. So how to run a Lite client is very simple. There is a repo called Avail Up. In that, this is a simple script. If you run this script, it will automatically fetch the latest. It will run the Lite client. It will generate addresses. It will do all the things that it needs to do to be able to run a Lite client. When you run a Lite client right now on the Goldberg incentivized testnet that we are running right now, you might get an error or a warning on the bootstrap. Ignore that warning for now. We have multiple bootstraps. The first bootstrap is giving a warning here. Ignore all of that. This is a Lite client running. When you are running a Lite client, you can also use the HTTP interface on top. I think this. So what you can do is on the Lite client, you can, yes. So you can see the status, what network is it connected to, what versions are it using, everything. This is the V2 interface. The V2 interface is somewhere here. So you see the API version V2. You can see the blocks, the sync status, the block numbers, etc., etc. You can even go and submit a data using our Lite client. So this is all happening through the Lite client. You are not connected to an RPC directly. You are connected only to a Lite client, and you can post a particular data. Here I'm posting this data. This is all base 64 encoded. You can use this data to go ahead and submit onto Avail. Why are we waiting here? It's because this is getting submitted. Once the submission goes through, you will get a transaction hash. Using the transaction hash, you can go to an explorer. We have 2 explorers that we have right now. Two have different properties. So if you put the transaction hash here, you will be able to see the submissions. It would look something like this. Yeah, I think yeah, you will be able to see what kind of data that it had, what kind of proofs that it generates, and so on and so forth. You can do the same, but using something like Golang. I think this. So you just need to put in this, and then the data can be submitted directly on Avail, and this is the data that got submitted right now. You can also use something like JavaScript. So this is a JavaScript example. Just do an npm run data submission using our Avail.js SDK. You'll have to wait till it gets submitted, but once it submits, and again these are warnings and other information, you will be able to see something like this. Here again, this is the data that got submitted, the transactional details, the payments and all. You can ignore most of it, but once you have all of this, you can also use Rust. By the way, our Rust examples are here. These are the examples about how to generate account from a mnemonic, how to use the bridge to send messages, how to synchronize the latest header, how to query a proof, submit a data, and a few other things that are there. Again, all the examples on how to run are all here. You can check it out. The same goes for Go examples. The Go examples are here: how to connect to a node, how to submit and then wait for its inclusion, how to query the proof data, listen to new blocks, transfer funds from one node to the other, and so on and so forth, right? So all of these are Go examples. The same with JavaScript. You can see here, like connecting, creating an application ID, as I was mentioning, and so on and so forth. So yeah, these are all examples. Hold on. Okay, cool. So yeah, I think that's almost it. There is a Telegram chat, there is a Discord. This is a Discord server where we can chat a lot more. There's a Telegram chat there. We can discuss. And if you have any questions, reach out to us. This is me on Twitter. That's Avail project. Thank you.